This is an example of graphing a parametric equation. In a parametric equation, we have a function that controls the x-coordinate and we have a function that controls the y-coordinate. And these are controlled separately. This makes every point of the form t squared minus 2 comma 3t, in other words, x comma y. So to graph this one, we're going to plot a bunch of points. We're going to plug -3 into both and -2 into both and so on. So let's just do, how about the x's? We have 9 minus 2. That's going to be 7. With -2 plugged in, we get 4 minus 2, that's 2. 1 minus 2 is -1. Plug 0 in, we get -2. When we plug 1 in, we get -1. 4 minus 2 is 2. And then 9 minus 2 is 7. With the y's, we can plug -3 in, and we'll get -9. -2 is -6. -1 is -3. When we plug 0 into 3t, we get 0. And then 3, 6, and 9. Now we'll plot the points. Now we can forget about t. And we have the point 7, -9. 7 and then -9 is down here. 2, -6. We have -1, -3. -2, 0. Then we have -1, 3. 2, 6. And 7, 9. So there's 7, 9. And now we play connect the dots and we have this parabola. I missed a little bit. There we go. And this should be a nice parabola. It's a little hard to draw with this tablet. But we also show the arrows. We can show direction with parametric equations. And this is the path that the equation follows right there. If we are asked to find the rectangular form of this parametric equation, we just need to solve for t on one of these. Now if I solve for t in this one, we're going to have plus or minus the square root. So it's going to be a little bit more convenient to solve for t on this one. So t is equal to y over 3, and then we can plug y over 3 in for this t. We have x is equal to y squared over 9 minus 2. So there's the rectangular form of this parabola. Here are some tips when doing the homework. If you're given y equals 3 cosine of t and x equals 4 sine of t, and you're asked to find the rectangular form, we're going to try to eliminate t here. But what we notice is sine squared of t plus cosine squared of t is equal to 1. So we can solve for cosine of t. We have y over 3 is equal to cosine of t. And we have x over 4 is equal to sine of t. Well, if sine squared plus cosine squared equals 1, then x squared over 16 plus y squared over 9 should also be equal to 1. And that is the rectangular version of the parametric equation. We also have x equals the absolute value of t minus 1, and y is equal to 3t minus 2. Now it's okay to have an equation say x equals rather than y equals. So in this case, we would have y plus 2 is equal to 3t, and then t is equal to y plus 2 over 3. So to find the rectangular version, we can have x equals instead of y equals. So now in this case, x is equal to y plus 2 over 3 minus 1. The back of the book would probably have this with common denominators. So we'd have y plus 2 minus 1 over 3. We could have x equals 1/3 y. This would be 2 minus 1 is 1 plus 1/3. It's also nice to know the other Pythagorean identities. We start out with sine squared t plus cosine squared t is equal to 1, and then we can find the other two just by division. So if we divide by, let's say, sine squared of t, divide by sine squared t, and divide by sine squared t, we would get 1 plus cosine over sine is cotangent squared, and 1 over sine squared is cosecant squared. So there's another Pythagorean identity. Then if we do the same thing, we start out with sine squared t plus cosine squared t is equal to 1. We can divide by cosine squared t. So divide by cosine squared t, divide by cosine squared t, and we get tangent squared t plus 1 is equal to secant squared t.